Okay, so we're going to talk about acid-base mixtures, and I lost my video, so I'm doing this video over again on top of the stuff I've already written. So here we go. When you have an acid and an acid mixed together and the strong acid is present, it will dissociate 100%, so it is going to be controlling the pH. That's why I say strong acid controls the pH. Weak acid is only there to take up space, so it's going to be there to add volume. So how do you get the millimoles or moles of H? You take the moles of the H plus from the strong acid divided by the total volume to get the H plus concentration. Plug the H plus concentration into your pH formula to get pH. Note to self, don't forget that the way you get moles of H plus is to times molarity times volume to give you moles. That's why I just made up an example of 0.1 molar of HCl times 0.1 liters to give me moles. That's only if you have a mixture between a strong acid and a weak acid. If you have a strong acid, they both matter. So if they both matter, you have to take N times V of each strong acid and add them together. So it's total moles of H plus from both strong acids. Still think you do have to divide by total volume because it's a diluted sample. It's a larger volume. Add up both your volumes for the total volume. Get pH the same way we just did. If you have a strong base, weak base, then you have to indicate you're solving for OH minus concentration, not H plus concentration. So same way, how do you get moles? You take your M times V of your strong base to get the moles of OH minus, and then you divide by your total volume. The weak base doesn't matter except for the volume of it. OH minus concentration will give you POH, so don't forget you do 14 minus POH to give you pH. If you have a strong base, you get total moles of both of the OHs by doing M times V for the first one and then M times V for the second one. And adding those moles together to get total moles of OH divided by total volume again. That's going to give you OH concentration. Don't forget OH is going to give you POH, so 14 minus POH. Last type, so these are the four main types of mixture problems. This last one is a little bit hard because you actually have to do a reaction first. And this reaction requires you to find limiting reagent and excess reagent. So I try to make an example with green colors and blue colors. You've got moles of acid. How do you get moles? You do M times V. You get moles of base. When I looked at my example here, I have a 1-to-1 mole ratio, so this one's easy. You take your, look at both of your moles and figure out who runs out first. In this example, it's the one that's the smaller number will run out first. I assumed my green number of moles was smaller than my blue number of moles, so my LR was my base. All of that base gets wiped out, so I end up with 0 of it left. I have a little bit of acid left over, so what I'm doing is I'm minusing my moles of base from both sides here, minusing my moles of base over here. That's because they react in a 1-to-1 mole ratio. Subtract, and you have some moles of acid remaining, so right now you should know the pH should be fairly acidic. Don't forget that you still have to get to molarity though, so you take your moles divided by your volume. So your moles of acid divided by volume total will give you molarity again. Molarity will give you H plus concentration, which will give you the ability to find the pH. We went through 3 examples, one of each type. And I'll let you look here and copy down what you need to. First thing we did was identify the type of reaction. We saw strong base, weak base, so we ignored the weak base really until we got to the volume part. We had to get to OH concentration, so we found our moles by doing M times V divided by our liters to get to OH concentration. So here we go. We got 0.0020 moles of OH divided by 25 milliliter sample because this volume together is 10 plus 15, giving me 25 milliliters, which is 0.025 liters. This gives me my OH concentration of 0.08 molar. Plugging that in gives me a POH of 1.096. 14 minus pH gives me 12.90, which is my pH, which makes sense because it's a strong base, so it's fairly up there. My second example included a strong acid and strong acid, so both of them mattered. So I did M times V of this one and M times V of this one to give me moles of both. You'll see that work over here in red. Moles of the first one, moles of the second one. Sum them together, you got 9.5 moles, and I did millimoles because I didn't want to move my decimal. So 9.5 millimoles divided by 225 milliliters gave me an H plus concentration of 0.38 molar. and then plugging that into their pH negative log gives you a pH 0.42, which is really acidic, and that makes sense because it's a strong acid. Last example was one where you had to do the reaction. This is the only one that requires a BCE. So we had a strong acid and a strong base reacting. I set it up the same way we previously did in the example problem. My base delivered 10 times 0.2, so 2 millimoles. My acid delivers 15 times 0.5, which is 7.5 millimoles. I looked and I saw that I had less of the OH, or the sodium hydroxide, so that's going to run out first. This will run out by taking away 2 millimoles and leaving you with 0 left over. This will run out by only consuming 2 millimoles of that acid, because it's a 1-to-1 mole ratio as indicated by the BCE. You're left with 5.5 millimoles of the acid, 5.5 millimoles of HCl specifically here, divided by my total 25, which was just taking both the volumes and adding them together. Dividing by 25 milliliters, I'm allowed to cancel out milli of the millimoles and milli of the milliliters, and that gives me moles per liter, which is molarity. I get 0.22 molar, and then plug that into pH calculation, and I get 0.66 as my pH. Let me know if you have questions. Thank you very much. There's another video on the most complicated problem on the problem set, so I would look at that one too.